All right, everybody, hi. This is a more annoying voice than the videos that you're used to. It's me. First rule, no laughing at my video, the sound, the notes, or anything. Here we go. We're going to do some proofs. You know proofs look like this. They have statements and reasons. Previously, we've done algebra proofs where we wrote some statements here, like we would have an equation 5x plus 2 equals 20. We would take away 2 from both sides and we would write subtraction property on the right. So we're doing triangle congruence proofs now. The statements that we're going to write on the left side of our proofs are going to be things like one side of one triangle is congruent to a side of another triangle. So this might be something we would write. Or angle A is congruent to angle T in another triangle. And we'll find out how we're going to list those in a minute. Mostly they're going to be given. And then the reasons here is what we're talking about today. The kinds of things we're going to be using a lot in these proofs. And they are all things you've learned before, but you probably forgot, so I'm going to remind you what they are. So I have an arrow here. That's because all of these things will be one of your reasons. Besides the word given, sometimes a problem is going to already tell you that some things are congruent to one another, and then you can list those as given. You'll see that in the next video. This is just a review of some things. So let's read this together. You'll be completing proofs for the rest of the chapter. A proof is written in 2 columns. On the left, we write the steps called statements. That's just like before. And on the right, the justification, which is called reasons. So we did this with algebraic proofs. Now we will list congruent parts of triangles and see if there's enough information to know that the triangles will be congruent. This is all about finding congruent triangles and listing the parts that we can find that are congruent to see if we have enough information to know that the triangles will be the exact same shape and size. And one thing I want to warn you about, a lot of the products, the book, pictures, diagrams are made so that the drawings, the triangles look exactly the same. But you can't assume they're congruent. That's what this is all about, because we're teaching you the logic of writing out an explanation, kind of like the equivalent of writing an essay in an English class. And the kind of explanation we're teaching you to write is called a proof. Okay, so here we go. It might be painful. So in geometry, you cannot just write they look congruent. You have to be able to give a fact that we have learned about definitions or rules in previous chapters. These things are called theorems. I didn't want to get you caught up on vocab, but those rules are called theorems. We've learned them before. So here we go. For the triangles congruence proofs, these are things that come up a lot. The first one is the reflexive property. So that's one thing that you're going to be using a lot as a reason. And I'll show you what that looks like in a triangle congruence proof. You know, reflexive property meant everything is equal to itself. Every value equals itself. That's what the reflexive property said. And I told you back then we're not going to use it a lot. But here's one place where we're going to use that something is equal to itself. And the other one, the second one, is that vertical angles are congruent. This we've been talking about a couple times already. As reminders, we did it last week. Found some vertical angles that were congruent. The other ones, which you probably have forgotten, our definition of a midpoint. And the actual definition of a midpoint is it's a point, and I'm going to abbreviate the word point like that. And what it does is it divides a line segment into two equal parts, or two congruent parts. Let's say it that way. So if you know you have a midpoint in a problem, then you know you could say that the two parts are equal. And the other one is definition of an angle bisector. Let's put angle in front. Definition of an angle bisector. And that's a ray or a line. Let's just say line. And it divides an angle into two congruent parts. So that's going to help us find congruent angles in our pictures. And another one that comes up a lot has to do with parallel lines. So I think it was chapter 3, we learned about parallel lines, and you have to look for an arrow, or you have to see the word parallel. You can't just assume they're going in the same direction. And then when you have a Z shape, these angles in here are congruent, and that Z shape comes up a lot. I'll show you what kind of pictures that comes up in related to triangle. So with two parallel lines and a transversal, those are called alternate interior angles because they're between the lines and on different sides of the transversal. So we'll write it out. Alternate interior angles are congruent, and we usually abbreviate this AIs, so you could abbreviate that, okay? These are the kinds of things we're going to list as reasons in a proof. So here we go. These are the things, this is how you're going to use them, and then you'll put them in the proof in your next lesson. So a description. So the first thing, the reflexive property. So this is for reflexive property. That's number 1 that we wrote above. The description is you're going to have a common side, or you could use the word shared side in two triangles. I'm not going to write the word triangle. We're going to use it a lot. I'm just going to put that. And is a picture enough to know? The answer is yes. So you can assume that in a picture like these, if you see a side that two triangles share, like here, the orange triangle shares a side. I don't know why my pen's not running. With the purple triangle. Let's make the one yellow. So you see that side in the middle there, it's both a side of the yellow triangle and a side of the purple triangle. So when we separate the two triangles, and think, you don't have to actually draw them separately, but you can, I like to. This side is equal in the two triangles because it's the same side. It's this same side. So we call that reflexive property. And here's another case where two triangles could be overlapping, sharing a side. And then this one, I forgot to draw this diagonal across. Would you please draw that in for me? That would be a shared side. You see you have a triangle up here that has a side on the diagonal, and this one, it's the same side for the purple triangle. So these are most commonly the types of pictures you'll see. So what we're going to do is we're going to put this dash, instead of drawing the triangles separately, you don't have to, you can just put a dash there, and that shows that in the two triangles that side is going to be equal. Same thing on this, you could put a dash to show that that side is equal in the two triangles. And same thing with this other one, you're going to be able to put a dash in it to show that that side is equal. And so a statement might look like, so let's call this side maybe AB. A statement on the left side of the proof would look like side AB in the yellow triangle is congruent to side AB in the purple triangle. You won't be using colors, but I just want to emphasize right now. So our two sides AB in our two triangles are congruent. It's the same side. And then in the proof, the reason we're going to write for that is the reflexive property. That's because that's what tells us, that's what we name the rule that says everything equals itself. And this is really one of the only places we use it, is in these proofs. Okay, the second one is vertical angles are congruent. So I'm going to abbreviate. We've reviewed this a couple of times. Vertical angles are congruent. And I don't really have anything to add there because we've talked about that a couple of times. And is a picture enough here? Yes, definitely. It's enough. So what do I mean? I mean, if you see a picture like this and you have a pair of vertical angles, then you can go ahead and mark in your picture. You can add marks to the picture and write the statement. You could either put numbers in there and say angle 1 is congruent to angle 2, or you can use 3 letters. A lot of the time we use 3 letters. So if there were 3 letters here, you would say angle ABC, maybe in triangle DBF. So that's the kind of statements you would write. And the reason would be here, vertical angles are congruent. That's what you would write on the right side in your proof. So we've used that before, we just haven't written the explanation. All right, next one is the parallel lines and the transversal. So this was number 5 up there. This is AIs. So if you have parallel lines, I'm going to abbreviate it that way. Then your AIs are going to be congruent. So here you need to, a picture is not enough. I mean, picture is enough if you see the arrows to show that your lines are parallel, or you need to see the words. So that one line is parallel to the other. So here's a picture. So let's say we had that this line is parallel to this line. Then, of course, I forgot to draw this other diagonal. You can look for some AIs, and you'll know that they're congruent. So where are my AIs? Here's a Z in this picture. And in the corners of the Z, that one and that one are alternate interior angles. So we could say that this angle is congruent to this angle. So if you wanted to, you could name them angles. So let's put some letters on this. Let's say this is rectangle A, B, C, D. Sorry, I forgot to put those. Then we would say angle B, A has to be in the middle because that's a vertex. BAC, angle BAC is congruent. I'm writing this in the last column. And then this one on the bottom would be called angle AC has to be in the middle because that's the vertex, D. And that's one way you could write it, or you could put a number 1 and 2 in there. That's what I usually do. So then you would say the reason on the right is because AIs are congruent. And you have parallel lines. So if you did it in this, you should add this to the picture if your lines are parallel. Or here, if those lines are parallel, on the other picture, you have something like this, or it could be sideways like this. As long as these two are parallel, then you have some AIs in there that you could say are congruent. So for example, this one, there's the Z, is congruent to this one. And actually here you have two pairs. This is a little triangle, so I'm going to just put 1 and 2 in there. So angle 1 is congruent to angle 2. And then there's another pair of AIs because there's this Z here. Of course my orange pen is not working. Let's go with the yellow. That's our other Z, so this angle right here and that angle right there are also congruent. So in a case like this, you have two pairs that you could pick out. Angle 3 is, oops. Why did I write 3 there? I should have written 2, sorry. No laughing or getting angry. So angle 3 is congruent to angle 4. That's another thing you could write on that picture. These are separate pictures, separate examples. Okay, I'm rambling on too long, so here we go. Here's the last two. This is number 3 we did up there. And that is if you have a midpoint, it makes 2 equal parts. Or 2 congruent parts. So that's that one. So what does that look like? You have a little line. So if the words say that M is the midpoint of AB, remember you can't assume it from the picture. So you can't just look at this picture and say, oh, that's got to be the middle. You have to see these words. Okay? Here you need words. You can't just assume it. You can't just look at a picture. So if you have that, the words that M is the midpoint, then, so if you're given M is midpoint, then of AB, then you could add to your picture this. This part is equal to that part, and you would write piece AM has to be congruent to piece MB. We used to do that in chapter 1. And so the reason when you write this, the two parts, is you're going to write a definition of a midpoint. So I just want to show you really quick. You don't have to write this, but a place where that's going to come up later is like you might have two triangles like this stuck together. And then you're given that A is the midpoint of BC. don't write this. You'll see it next time. I just want to give you a heads up. So what does that mean? That means on your two triangles, this piece is going to be equal to that. And so then you could write BA is congruent to AC. And in your two triangles, you're picking out this side of this one on the left and this bottom side of the triangle on the right. That's what we're going to do. And the last thing is the angle bisector. That divides also two congruent parts, but this time it divides the angle into two congruent parts. So here, if we have that BD, that's this, is the angle bisector of angle ABC. Angle ABC is this one. A, B is the vertex, C. So what can we add to that picture is that this piece is going to be equal to that piece. It's going to divide that angle at B, at the vertex, into two equal angles. And so we would write as a statement, angle ABD is congruent to angle CBD. You're going to use this to prove two triangles are congruent. You could see them here already. You could pick out those angles. And if you wanted to, you could throw a 1 and a 2 there. And you could also write angle 1 is congruent to angle 2. That's an easier way of doing it. Then the reason you would write, in the last column we're listing the reasons, you would write definition of bisector. So I'm going to have you practice a couple of those. Thanks for listening and not laughing. I do have a famous, popular YouTube channel. I think I have 8 followers. Just wanted to make sure everybody knew that. I'll check and see. Maybe I have more now, but it's pretty popular. Okay. See you later. Thanks, people. Bye.